Super radiance. Super radiance, chat. What is super radiance? Well, super radiance is the mechanism by which we are amplifying energy in the MH370 videos. That's the mechanism by which the plasma balls, whoop, psh, that's the thing that Salvatore Pais is talking about when he says equations 7, 8, and 9 of his electromagnetic, high energy electromagnetic field generator. That's what he's talking about. So, given this information, I'm going to dig into it in a second. Number one, it's probably not a fusion bomb. It might be a fully electromagnetic effect that they're doing on the plane, which honestly freaks me the hell out. These are straight up psychopaths, chat. We are well beyond any kind of sociopath thing, full on, fully fledged psychopaths, breakaway civilization shit. I just got to reiterate it. We're to the point where there's so many Nobel Prizes ahead here. Really starts to make my head spin a little bit. One thing you're going to note about super radiance right away is that super radiance is tied to quantum mechanics, quantum mechanical effects. And pretty much everything in the MH370 video has been tied to quantum mechanical effects. The reason why these plasma balls look like stable, solid structures just spinning around, they're superconductive. Spacetime PBS, one of my favorites. Used to watch this guy all the time. Let's have him explain some super radiance to us. And again, these are all like new things. What I'm going to teach you here about super radiance, these are relatively new discoveries that people have found out about physics from experimentation that generally classic physics struggles to be able to explain. They'll come up with some bullshit, but end of the day, we know it's the ether. We know 0-point energy is the answer. So when we look at this stuff, we go, oh shit, this is crazy. This proves our theories. Here we go.
So normally, if you radiate a bunch of atoms or molecules with a bunch of photons, each might absorb a photon, bumping an electron to a higher energy level, and then radiate another photon as the electron loses that energy. When the emitted photon has lower energy, then the process is called fluorescence. The de-excitation of many excited electrons takes a bit of time as they decay randomly one by one, so fluorescent materials glow for some time after being illuminated. Superradiance is a bit different. It can occur when a group of atoms or molecules get into excited states as an entangled group rather than individually. That can happen, for example, if the spacing between excited particles is smaller than the wavelength of the incoming photons, then we can't say which particle absorbed which photon, so we have to treat the collection of particles as a single quantum superposition state of all possibilities of the absorption matchups. In any case, if the system of particles is in a collective excited state, then it tends to decay collectively, so photons are emitted together.
Okay. One thing I'm going to pause so that I don't get a copyright strike, because I'm lazy and I don't want to edit the video, but also to already explain when we're looking at this here, if you've been watching my content, the wheel should be spinning like crazy right now when you're looking at this. What are we looking at here, chat? Magnetism. What is magnetism, chat? Magnetism's when all the atoms, all the electrons are aligned in your metal. That's how you magnetize something. You get everything to line up. This is also dynamic nuclear polarization, controlling the spin of the atoms, which has been linked to anti-gravity. It's also coherence. All of these things are all true simultaneously. But right off the bat, what am I getting at here? I'm getting at, you can tell right away that if this is true, this is a pathway to Hal Puthoff's polarizable vacuum. How do I manipulate space-time? If space-time is a random soup This way. A random soup of positive and negative charges. Well, if I want to manipulate it, I need a focused charge. I need a super magnet. I need everything to align perfectly. Not a little bit, like perfectly. Perfect precision. Oh, well, it turns out that's exactly what superradiance is doing. Okay, back to the video.
This results in a much brighter and shorter spike of radiation than regular fluorescence. Another way to think of this is that the emission of photons from one electron in the ensemble prompts many identically excited electrons to decay, amplifying the first electromagnetic wave, which, by the way, is also exactly how lasers work, and superradiance is sort of a scaled-down example of the laser phenomenon. So, superradiance is a very quantum effect, and these researchers claim to have observed it in actual microtubules. More precisely, they claim to see...
I have to say something else. It's also how lasers work. That's not an accident, chat. We're amplifying energy with a laser, right? Stimulated emission or what is it? What does laser stand for again? I always forget. Laser acronym. Okay. Stands for light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. That's what laser stands for. So what am I getting at here? I'm getting at they're using the same principles of a laser to amplify energy, but they're doing it with plasma. Why? Because plasma is electromagnetic itself. So instead of doing it with a laser beam, use a plasma ball and have your plasma ball be charged either positively or negatively, have them converge, and now you're going to have a super radiance effect occur. Do you know who developed one of the first tunable lasers in this world? Hal Puthoff. Do you know who wrote a book on quantum mechanics for Stanford? Hal Puthoff. Huh. Interesting. Interesting that the guy that was building tunable lasers and optical computers for the United States government also happens to be the world's leading expert on zero-point energy. Might be a connection there for you guys. We'll come back to that.
The superradiance in the tryptophan amino acids within tubulin molecules when radiated with ultraviolet light. If this is right, it would require large-scale quantum entanglement of tryptophan molecules across the microtubule. Although the researchers didn't directly measure that entanglement or its source, according to their models, the amount of light emitted was hundreds of times that expected from simple fluorescence, and so could have only been possible through a super radiant process. The researchers also did...
So that's interesting because we got a little bonus there. That was being linked in 2024 to microtubules in the brain. What they were saying is that they're trying to explain where consciousness comes from, where thought comes from. They're saying, what if there's super radiant effects happening in our brain, and our brain is doing that, amplifying energy, and that's somehow interacting with space-time? Multiple charged objects, let's say, electromagnetic radiation, and we can interact with them. They can get into phase naturally, just like our synchronized clapping. And this will lead to something called a super radiant effect. This will lead to an amplification of energy, just like Salvatore Pais says. So let me play the clapping video for you guys first.
This is an audience in Budapest applauding after a performance. But what happens next is completely spontaneous. They're not being instructed by anyone. See if you can spot the phase transition.
Clap, my seals, clap for me. But that's the answer right there. And this is what they figured out from thermonuclear weapons. This was the big secret. They figured out from thermonuclear weapons that there was this synchronization, quantum synchronization that occurs that can amplify energy. And when you start dealing with amplification of energy, this is where it becomes now possible to break the Schwinger limit. So let me run through some details on how superradiance works. So as a real world example, imagine a room full of atoms. Normally they would flicker out one at a time. But in superradiance, they all decide to flicker out simultaneously. So this has been observed in atomic clouds, meaning this is not just a situation where people have seen this in energy. This has been seen in matter. Clouds of atoms, plasma perhaps, have shown this effect. And what this means, as we pointed out, that each atom, you would treat it as having a spin, up, down, etc. And now we're saying that these atoms are all in a collected, excited state, meaning they all share the same radiation field. Their dipoles are all locked in phase. Everybody's perfectly lined up. And you realize, oh, so we've got a traffic jam here. So now we can control the flow because everybody's been locked into phase. This is exactly one of the theories for manipulating space-time. This is Hal Puthoff's polarizable vacuum model. When Hal Puthoff reads this, he goes, "Oh shit, dog." This is how Hal Puthoff talks. He goes, "Oh shit, dog, that's definitely my shit right there." He goes, "You do that, you're gonna mess up some space time." He's got some sass to his voice, a little bit Southern, a little African American. Combo it up. That's what Hal Puthoff's talking about. He's saying the 0-point energy is electromagnetic in nature, space-time itself, the backbone of space-time. And so if you start messing around with polarizing, getting everything to line up like this, you're going to start to see physical effects. Real physical effects are going to occur because you're changing the permeability and permittivity of space-time. You're changing the refractive index of space-time. You're treating space-time now like a medium.